In this lesson, we're going to cover section 4.5, the coefficient of determination. We'll do an example, and then we'll do another example where we'll start tying everything together, where I'm going to show you how to, if we have a paired data set, how to create a scatter plot, how to calculate R, and how to calculate R squared. So first, let's talk about R squared, the coefficient of determination. So another important statistical measure that can be calculated from the correlation coefficient R, which I taught you about in the last lecture, is called the coefficient of determination. This measure is used to explain the degree of influence that one variable, the independent variable, has on the other variable, which is the dependent variable. So I have a bunch of bullet points here. The coefficient of determination measures how close the data points are to the regression line. The regression line is, and I'll talk more about regression analysis in the next lecture, but just think the line that best fits that scatter plot. So the higher the value of the coefficient of determination, the higher percentage of data points the line passes through when the data points are and line are plotted together. We use R squared. Try that again. We use R squared to represent the coefficient of determination. And we typically write it as a percent. So R squared is always going to be a value between 0 and 100%. And the coefficient of determination is just the correlation coefficient squared, or R squared. Remember, the correlation coefficient, which I spoke about in the previous lecture, measures the strength of the linear relationship between two variables. So we can think of the coefficient of determination as representing the percentage of variation that can be explained by this line, the equation of the line that's going to pass through this data. So it measures the proportion of the variance of the dependent variable y that can be accounted for by the variance of the independent variable x. And I know that sounds confusing, but once we look at example 5, I think it'll make a little bit more sense. So to sum up, the coefficient of determination measures the proportion or the percent of the variance of the dependent variable that can be explained or accounted for by the variance of the independent variable. And we calculate the coefficient of determination by squaring R, the correlation coefficient. So we use R squared to represent the coefficient of determination. So in this lecture, I will teach you how to calculate R and how to calculate R squared. But before we do that, first I want to do an example where we have to just interpret R squared. So we'll do an example where we have to interpret. So that'll be example 5. So it says the data below are the number of hours worked per week and the final grades of 9 randomly selected students from a drama class. The coefficient of determination, R squared, is equal to 0.982. So I already calculated it for you, and all I want to do is interpret it for this example. So let's interpret R squared. So your general interpretation really is right here. So we can always think of the coefficient of determination as the percent or proportion. I typically like to write it as a percent. So think percent, I'm just going to put percent above proportion, of the variance of the dependent variable that can be explained or accounted for by the variance of the independent variable. So look, in this example here, we have X, which represents hours worked per week for a student, and then Y represents their final grade in a drama class. So the independent variable is always X, and that's going to be the hours worked in this case. And then the dependent variable is going to be Y, which is the final grade. And it makes sense because we would expect the final grade to depend on how many hours a student works per week, not the other way around. So if R squared is equal to 0.982, we could write that as a percent. Remember, we multiply the decimal by 100, so we would get 98.2%. So let's interpret this. So what we say is, and if we follow the definition of the coefficient of determination that I have highlighted up here, what we say is, we can say that 98.2% of the variance in the final grade a student scores which is the dependent variable, can be accounted for by the variance in the independent variable, which is the number of hours worked per week. So we say that 98.2% of the variance in the final grade a student scores, which is the dependent variable. So we could, if we look at the final grades, there's variability within the grades, right? This can be accounted for by the variability or the variance in the number of hours that a student works per week, which is the independent variable. We can also think of this in another way too. So the number of hours worked is not going to be the only factor that's going to influence final grade, right? We could explain the variance in final grade, 90.2% of the variance in the final grade by the number of hours worked. But what about the other 1.8%, right? So 100% minus 98.2% would be 1.8%. So we could think of this too as 1.8% of the variance in the final grade is due to other factors, could be accounted for by other factors. So that's how we interpret the coefficient of determination. And at the end of this chapter, we're going to do 2 more examples where we're going to have to interpret the coefficient of determination. So we'll have more practice with that. So what I want to do now is I want to show you how to calculate these values. So in this example and the previous examples that I did in the previous lectures when we were interpreting R, we didn't have to calculate it, right? I was just giving you R values and we had to match the appropriate graph and so on and so forth. So now let's talk about how we're going to calculate R and R squared. Well, R squared comes from R. We just have to square it. So how do we get R? Well, remember, in the previous lecture, I showed you this formula and I explained it to you, right? This is the formula on how to calculate R, and I explained it in terms of z-scores. This is a tedious formula, especially if you have a lot of ordered pairs. This is a lot of work to do by hand. So we're not going to calculate Pearson's correlation coefficient R by hand. We're going to use the calculator. The calculator already has this formula programmed into it. So that's what I'm going to show you how to do now. And we'll do an example with a data set. I also have the calculator steps here for you as well. So here's the calculator information. So it's going to cover how to draw a scatter plot, which we'll do. And then below that, I have the steps on how to find R and R squared, and then what I'm going to introduce in the next lesson, which are the regression coefficients. So we could find those all in one function. So you have the steps here, and I'm going to go along with the steps using my calculator, and I'll display that for you. So let's look at example 6. It says the data below are the final exam scores of 10 randomly selected calculus students and the number of hours they slept the night before the test. Calculate the linear correlation coefficient R and the coefficient of determination R squared. So once we have R, then we can calculate R squared. And like I mentioned before, there's a function in the calculator where we can calculate R. And you know what we'll do too? We might as well make a scatter plot too. Let me teach you how to make a scatter plot using this data. So you could think of these pairs as ordered pairs, right? Because hours represents X and scores represents Y. So for example, we have, whenever we write an ordered pair, right, we write X comma Y. So we could think of the first ordered pair as 4 comma 74. The second ordered pair, for example, would be 6 comma 89, and so on and so forth. So if we were to actually plot these ordered pairs on a set of axes, that would be our scatter plot. But again, we don't have to do this by hand. We have a graphing calculator. So let's have the graphing calculator make the scatter plot for us. And that's what I'm going to teach you how to do now. And then I'll show you how to calculate R and R squared. So the first thing you have to do is enter your data values into a list into the calculator. So I'm going to pause so you guys have a minute to enter these two sets into the calculator. So it doesn't really matter where you put these lists. Put the hours in one list and put the scores in another list. And then I'll show you how to calculate the correlation coefficient and R squared, and we'll do a scatter plot as well. So my lists in the calculator are L3 and L4. So the hours I put in L3 and the scores I put in L4. So first, let me show you how to create a scatter plot. So let's go to the calculator together. So you'll see here's my list 3, my list 4. I have my data values in there. So the first thing you want to do is, especially if this is a calculator that you've used before in another class or you borrowed it from somebody, you want to make sure that when you press Y equals, so the button right underneath the window, Y equals, because that's the equation editor, you don't want to have anything in there. So if there's any equations in here, just clear them out. You don't want any equations in here right now. So make sure this is empty. And then what we're going to do is we're going to press second and then Y equals, because you see in blue above Y equals, it says stat plot. That's where all our statistical plots live. And you'll see we have 1, 2, 3 plots here. Now, by default, if you haven't used any of these yet, they're all going to be off. And we only want to have one on at a time, just the one that we're using. I typically just use plot 1. So make sure plots 2 and 3 are off. If they're not, you could just arrow down to the one that says on. You could press enter, and then you would just, instead of on, you would just arrow over to off and hit enter and turn it off. So I'm going to choose plot 1. Now you have to make sure you turn it on. So make sure you hit enter on on. Now on should be blinking. Now we arrow down and we're going to choose the type of graph we want. And we're making a scatter plot right now, which is that first plot that looks like a scatter plot that the calculator's blinking on right now. So just hit enter. So it chooses that plot. Now arrow down again to your X list. Now you need to tell the calculator where you put the X values. Mine was L3, so L3 is already there. Put whatever list is appropriate to you. And my Y list was L4. So I'm going to leave this as L4. And then the mark is just what you want the calculator to use for the ordered pair. I usually just pick the first one, which is just a circle. You don't have to change that. And now once we enter all the properties here that we need, we're going to press graph, and graph is right underneath the window. Now don't panic. most of the time when you create a scatter plot this way, when you go to graph it, you're not going to see anything. It's because the scale, the X and the Y axes, weren't adjusted for that appropriate data set. And don't worry, it's a quick fix. So anytime you guys go to create a scatter plot and you don't see the points, what you're going to do is you're going to press zoom. Zoom is right in the middle underneath the screen. And you're going to choose option 9, which is zoom stat. And what that does is it'll automatically change the vertical and the horizontal axes to best fit our data, and it's going to make the appropriate window. So we're going to choose option 9, zoom stat. And you see now we could see this nice scatter diagram. And the first thing you should ask yourself is, okay, what type of relationship do we see here, right? And I definitely see a positive, right? Because as X is increasing, Y is increasing. So I could imagine fitting a positive line here. So this scatter diagram indicates that there is a positive relationship between X and Y. So now what I want to do is let's calculate R, the correlation coefficient, and then R squared. So this is how we're going to do it. So we already have our list in the calculator, right? Because we use them to create the scatter plot. So the way we're going to calculate R is go to stat, and then we're going to go over to calc. Actually, you know what I want to do first, because this isn't going to apply to everybody, but let's just all do it to be on the safe side. You have to turn your diagnostic on. It's a function in the calculator that's going to make sure everybody is able to see R when they go into that screen. So let's just quit out of here. What I'm going to have everybody do right now is go into the catalog. It's the 0 above the 0 button you see in blue catalog. So we're going to press second and then the 0 key. And this is alphabetical order. So I want everybody to find diagnostic on. You only have to do this once. Once you do this, you'd never have to do it again for the entire semester. So first is diagnostic off, then we have diagnostic on. So once you get to diagnostic on, you want to hit enter. It's going to pop up on the home screen, and then you hit enter again, and it's going to say done. We never have to do this again. It's going to stay on for the rest of the semester. So now we're ready to calculate R for this paired data set. So we're going to press stat. You're going to arrow over to calc, and you're going to arrow down to option 8. Option 8 is linear regression, A plus BX. And when we get to regression, I'll talk about what A plus BX is right now. But we're going to choose option 8. So hit enter. And you have to tell the calculator the appropriate list. So the X list that I used was L3. So I'm going to switch this to L3. And then my Y list was L4. So I'm going to leave that. Frequency list should be empty and store reg equation should be empty. The only thing you need is the X list and the Y list. And then we could calculate. And we get a bunch of output here. I'm going to end up going through all of this, but for right now, all we want is R and R squared. And let's go 3 places. So R in this case works out to be 0.847 if we go 3 places. And then R squared is about 0.717 if we go 3 places. So let's write this down. So R is equal to 0.847. And remember, R measures the strength of the linear relationship. So this is pretty high, right? This is pretty close to +1. So this is a fairly strong relationship between a person's score that they got on a test and the number of hours that they slept the night before. And then R squared is equal to 0.717. And remember, that measures the proportion or the percent of the variance in the dependent variable that could be accounted for by the variance in the independent variable. So the way that we can interpret R squared, we usually do it as a percent. So R squared is about 72%. So we could say that 72% of the variance in the scores can be accounted for by the variance in the number of hours that a student slept the night before. And this is how we calculate R and R squared. And we're going to do more practice with this. So the two examples that I have at the end of this worksheet, which I'll, spend two separate lectures on, will reinforce this and it'll allow us to practice more. So we'll end here. And then the next lecture, I'll talk about linear regression, and then we'll do some practice.